Welcome back. Let's practice solving perimeter problems. Alright, so here's our first example. We want to find an expression for the perimeter of the triangle, and then find the length of each side if the perimeter is 80 feet. Okay, so we're given a triangle here with three sides measuring 3x minus 4, x plus 1, and 5x plus 2. To find an expression for the perimeter of this triangle, you have to remember how to calculate the perimeter of a shape. And remember that the perimeter of any shape, not just a triangle, but any shape, is the measure of distance around the shape. So in this case, the perimeter of this triangle would be the sum of the measure of these three sides. So the perimeter P would be equal to adding these three sides together. So we'd have x plus 1 plus 5x plus 2 plus 3x minus 4. All right, we're just adding together these three expressions. Now, technically, we could be done. This is an expression for the perimeter, but we can simplify it. We have like terms here that could be combined, right? X, 5x, and 3x are all like terms that have the same variable part of x, so we could combine their coefficients and just have one term. And then we also have three constants that we can combine as well, 1, 2, and negative 4. So combining our like terms, we have that the perimeter is equal to x plus 5x, which would be 6x, plus 3x, which is 9x. So 9x, and then 1 plus 2, which is 3, minus 4, which is negative 1. So we get 9x minus 1. And that right there would be an expression that represents the perimeter of this triangle. All right, the perimeter is equal to 9x minus 1. So that takes care of the first part of this problem, but we also want to find the length of each side if the perimeter is 80 feet. So now we can make use of this expression, or this equation for the perimeter that we found. What we can do is let P, the perimeter, be 80, and then we could solve for x, right? We'd have 80 is equal to 9x minus 1, and now we have an equation that we learned how to solve earlier in algebra. What we want to do is isolate and solve for that variable of x in this equation, and once we have it, we can use that value of x to find the length of each of these sides. So let's isolate that term by getting rid of this constant. We can add 1 to both sides of the equation, so that's what I'll do here. And 80 plus 1 is 81, so we get 81 is equal to 9x. And then to solve for x, we want to divide both sides by 9, that coefficient of the variable term. So if we divide both sides by 9, 9 divided by 9 is 1, so they cancel out, and we'll have x is equal to 81 divided by 9, which is 9. So the answer we get here is that 9 is equal to x, or in other words, x is equal to 9, which is not our final answer, but it will help us get there. Now that we know what x is equal to, when the perimeter is 80 for this triangle, we can plug that value of x in for these expressions of the three sides of the triangle and find what they would be equal to. Okay, so starting with x plus 1 would be equal to 9 plus 1 if x is 9, and 9 plus 1 is 10, so we get 10 feet for one of the sides, right? The units that we're working with here are feet, so 10 feet is the length of this side. Then let's move on to this side, 3x minus 4. 3x minus 4 will be equal to 3 times 9 minus 4. 3 times 9 is 27, minus 4 is 23. So we get 23 feet for that side. And then finally for this side, we have 5x plus 2. And so 5x plus 2 would be equal to 5 times 9 plus 2. 5 times 9 is 45, plus 2 is 47. So this is equal to 47 feet. And that right there is the final answer to this problem. Those are the lengths of each side of this triangle if the perimeter is 80 feet. And you can check your work here. The perimeter being 80 feet means that the sum of all the lengths of the sides should be 80, and that would be the case here. 23 plus 47 would be 70, and then 70 plus 10 is 80. Okay, so you could write out the check work if you wanted to. It's not necessary in this case, but our answer here is correct. Okay, let's take a look at another example. Next up, we want to find an expression for the perimeter of a square with a side length of 10 minus 2x. And then, if the perimeter is 64 feet, find the side length. Okay, so this time around, we were not given a diagram of our shape, so let's draw it. That will help us visualize this problem. We are working with a square, so let's draw one. Remember that a square has 4 equal sides, and in this case we were given that a side length is 10 minus 2x. So I'm going to label that here. But really, all 4 of the sides would have that length, right? This is a square, so all 4 sides would be equal. All of them would measure 10 minus 2x, okay? So if we want to find an expression for the perimeter of this square, what we would want to do is add up those 4 sides of the square. But there is a quicker way to do that. We don't have to write that the perimeter P is equal to 10 minus 2x plus 10 minus 2x plus 10 minus 2x plus 10 minus 2x. We don't have to do that. What we can do is just multiply one of those side lengths by 4. All right, there are 4 of them, so you can take one of those lengths and multiply it by 4, and that would be the same thing as adding all of them together. All right, so a shortcut here is that for the perimeter P, it would be equal to 4 times that side length of 10 minus 2x. All right, so that's the setup for an expression that represents the perimeter, but let's simplify it. We can use the distributive property and multiply 4 by both of these two terms, right? We want to multiply 4 by 10 and then 4 by negative 2x. If we do that, the perimeter P will be equal to 4 times 10, which is 40, and then 4 times negative 2x will be negative 8x, right? 4 times negative 2 is negative 8, and then you keep that same variable part. And that right there would be the expression that represents the perimeter of this square. The perimeter P is equal to 40 minus 8x. All right, but now we are told that if the perimeter is 64 feet, find the side length. And we can do that if we set P, the perimeter, in this equation equal to 64 and solve for x. X itself doesn't represent the side length, but if we know what x is, then we can plug it back into this expression, 10 minus 2x, that does represent the side length, and we can figure out what the actual measurement of that side is. Okay, so let's set 64 as the perimeter in this equation. We'll have 64 is equal to 40 minus 8x. And remember, we are trying to solve for x here, so we want to isolate this term. And so the first thing we want to do is get rid of this constant term. I'm going to subtract 40 from both sides of the equation. So if we do that here, 64 minus 40 is 24. So we have 24 is equal to negative 8x. 40 minus 40 is just 0, so that's gone. And then to solve for x, we just need to divide both sides by negative 8. That will get rid of that coefficient of that variable term, just leaving us with x. So dividing both sides by negative 8, these negative 8s cancel out, and what you'll be left with is 24 divided by negative 8, which is negative 3, and that will be equal to x. All right, so x is negative 3, but that's not our final answer. That is not the side length. What we want to do is plug negative 3 back in for x for this expression that represents the side length of this square, 10 minus 2x. So let's plug that in over here. We have 10 minus 2x, but if you plug negative 3 in for x, you get 10 minus 2 times negative 3, and negative 2 times negative 3 is positive 6, so this is equal to 10 plus 6, which is equal to 16. And remember that our units are feet, right? We were told that the perimeter is 64 feet, so our final answer here is that 16 feet is the length of each side of this square if the perimeter is 64 feet. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. For our next example, we want to find an expression for the perimeter of a rectangle whose width is 5 meters less than the length. And then if the perimeter is 50 meters, find the length and width. Okay, so just like with our previous example, we were not given a picture of our shape, so let's draw one ourselves. That's going to help us visualize this problem. and ultimately help us solve it. This time we're working with a rectangle. So let's draw a rectangle that will look something like this. And what do we know about the length and width of this rectangle? Well, we know that the width is 5 meters less than the length. So we don't know what the length is, but we can just represent that with L. In each case, the length would be the longer side. But then the width, these two sides, are going to be 5 meters less than that length. All right, so really what we're doing here is translating a sentence into a variable expression where that variable expression represents the width of this rectangle. So this is something that we have done earlier in algebra, translating sentences into variable expressions and equations. In this case, the width is 5 meters less than the length. That word is translates to an equal sign. So the width W would be equal to 5 meters less than the length. Remember that that phrase less than refers to subtraction, specifically that you're subtracting the value before it from the one after it. So we're subtracting 5 from the length, which we have represented with L. So the width would be equal to the value of the length L minus 5. All right, that's what this sentence translates to. So each of these two sides, the two widths of the rectangle, have a measurement of L minus 5. All right, so now we can find an expression that represents the perimeter of this rectangle. Remember that the perimeter is just the measurement of the distance around an object. So in this case, we would add these four measurements together. But since it's a rectangle, and we know that opposite sides are equal, we don't have to individually add all these different sides. Instead, here's how we could represent the perimeter. P would be equal to 2 times the length, which we represented with L, plus 2 times the width, which we represented with L minus 5. Right? This is a shortcut for calculating the perimeter of a rectangle. You take 2 times the length plus 2 times the width, because there are 2 measurements of the length and 2 measurements of the width to account for. All right, that way you get the measurement all the way around that shape. Okay, so this would be our expression for the perimeter, but we can simplify it. We can use the distributive property right here and multiply 2 by both of these two terms. And so let's do that. We're going to multiply 2 by L and 2 by negative 5. Doing that will give us that the perimeter P is equal to 2L plus 2 times L, which will just be 2L, and then 2 times negative 5, which would be negative 10. So we have minus 10. Now we have like terms of 2L and 2L that can be combined, right? They have the same variable part of L, so we can add the coefficients. 2 plus 2 is 4. So our final answer here for the expression that represents the perimeter is P is equal to 4L minus 10. All right, that represents the perimeter of this specific rectangle, at least as a variable expression. All right, so that takes care of the first part of this problem. But now for the second part, it says if the perimeter is 50 meters, find the length and width. All right, so now we can use this expression for the perimeter that we found to help us out. If the perimeter is 50, then we can set P equal to 50, or in other words, just replace P in this equation with 50, and then we'll be able to solve for the length L, and then use that value to find the width, because we defined the width in terms of the variable L, which represents the length. All right, so we'll have 50 is equal to 4L minus 10, and this is an equation that we can solve. We want to isolate this variable term and solve for L. So the first thing I'll do is add 10 to both sides of the equation. That will get rid of that negative 10. And so continuing the work over here, 50 plus 10 is 60. So we have 60 is equal to 4L. Negative 10 plus 10 is 0. So there's nothing else over there on this side of the equation except 4L. And then to solve for L, divide both sides by that coefficient of 4. So if we divide both sides by 4, those 4s will cancel out. And then 60 divided by 4 is 15. So we get 15 is equal to L, which means that the length of this rectangle is 15 meters, which I'll just represent with 15m. And then for the width, since we know that L is 15, we can find W, the width, by plugging in 15 for L in this expression. So if we do that, we'll get 15 minus 5, which is 10. All right, so that's W. W is 10, which means that the width of the rectangle is 10 meters. And that is the final answer to this problem. Next up, we have the perimeter of a rectangular playground is 440 feet. If the width is 100 feet, what is the length of the playground? Okay, so the first thing that we should do here is draw a picture. Draw a rectangle that will represent this playground. We know that the perimeter P is 440 feet, so I'm going to write that down right away. P is equal to 440, and then the width is 100 feet. All right, so the width, these two shorter sides are 100 each. Okay, and we don't know what the length is, so I'll just represent each length with L. Now, what we want to do is find that value of L. So what we can do is set up an equation using the values that we've been given based on perimeter, right? We know that the perimeter is 440, and we know how to calculate the perimeter. You just add up all the different sides of the rectangle. And so we can set up an equation that involves that variable L that represents the length, and we can solve for it. All right, so the perimeter, 440, would be equal to the sum of these four sides. Or an easier way to write it would be 2 times the length plus 2 times the width, which is 100. Right? That's a quick way to calculate the perimeter of a rectangle. The opposite sides are equal, so you can take 2 times the length and add that to 2 times the width. All right, so simplifying, 2 times 100 is 200, so we have 440 is equal to 2L plus 200. And then what we have here is an equation that we know how to solve. We can isolate this variable term and solve for L. And the first thing that we should do to do that is subtract 200 from both sides of the equation. That will get rid of this constant term on this side of the equation. So let's subtract 200 from both sides. 440 minus 200 will leave you with 240, and that will be equal to 2L. And then finally, to solve for L, we just need to divide both sides by 2, the coefficient of that variable term. So if you divide both sides by 2, these 2's will cancel out, and then 240 divided by 2 is 120. So what we get here is 120 is equal to L, so the length of the playground is 120 feet, right? Our given units were in feet, so our final answer should also have units of feet. Okay, and so that's it. We have now finished this example. If the perimeter of this rectangular playground is 440 feet and the width is 100 feet, then the length has to be 120 feet. All right, let's take a look at one more example for this video. For our last example, we want to find an expression for the perimeter and then find x if the perimeter is a measurement of 78. All right, so this time around, our given shape is not a common shape like a triangle or a square or a rectangle. So to calculate the perimeter, we will just brute force add all the measurements of the sides together. All right, there's no special formula that we can use, and so we just have to add all these sides together to get an expression for the perimeter. But do notice that all of these sides involve the same variable part of x. All right, they all involve x, so we will use that to our advantage later. But first, technically, this is how you could represent the perimeter. P would be equal to the sum of all these sides. So adding them all together, we have 4x minus 1. And then we have 2x and 2x. So we'll have plus 2x, and then plus x minus 3 and x minus 2. So x minus 3 plus x minus 2. Then 2x minus 3 and x minus 2. So plus 2x minus 3 plus x minus 2. And then finally, our last side is x plus 5. So plus x plus 5. All right, now this would be true, and you could try to work with this. You could get rid of those parentheses and add like terms, but I think an easier way to go about this is just to group all of the variable terms and the constant terms together separately. So here's what I mean by that. What you can do is identify all the different variable terms. So we have 4x, 2x, x, 2x, x, and 2x, and add those all together at once. So we have 4x, that's from right here, and then 2x, and then 2x's. So 2x, x, then another 2x, and then 2 more x's, and then another 2x. All right, so 2x, x, and 2x. And we can just add all those up right now. They're all like terms, they all have a variable part of x, so you can combine their coefficients. 4 plus 2 is 6, plus 1 is 7, plus another 1 is 8, plus 2 is 10, plus 1 is 11, plus another 1 is 12, plus 2 is 14. So right there, we get 14x, and then let's combine all the constants. First, we have to identify them. We have -1. This 2x and this 2x don't have any constants. Those sides are just 2x, so we don't have to worry about those. But then we have -3, -2, -3, -2, and 5. All right, so altogether, -1, -3, -2, -3, -2, and +5. If we add all those together, -1 minus 3 is -4, minus 2, -6, minus 3 takes you to -9, minus 2 takes you to -11, plus 5 results in -6. All right, so that's what you get when you add up all of those constants. So together, the perimeter, or the expression for the perimeter here, P, would be equal to 14x minus 6. All right, that's the same thing that we would find if you were to combine all these like terms from this equation right here. I just find it easier for these types of problems to just write all those like terms in vertical lines so you can add them together quickly, okay? And from that, we get the expression that represents the perimeter of this shape. But now we also want to find x if the perimeter is a measurement of 78. Okay, so we don't have to figure out all the measurements of these different sides. We could do that once we have the value for x, but we're not told to do that here. All we have to do is solve for x in this equation if the perimeter P is 78. So let's do that here. I'm going to set up the equation over here. We'll have 78 is equal to 14x minus 6. And so this is an equation that we can solve. We want to solve for that variable of x. And so the first thing that we need to do is get rid of this constant term. So what we should do is add 6 to both sides. That will get rid of that -6. So we'll add 6 to both sides of the equation. And 78 plus 6 is 84. So we have 84 is equal to 14x. And then to solve for x, we need to divide both sides by 14. And so if we do that here, 84 divided by 14 is 6. So what we get here is 6 is equal to x. And that is the final answer to this problem. The value of x is 6 if the perimeter of this shape is 78. All right, and once again, you can now figure out the actual measures of these sides of the shape using this value of x. You could plug 6 in for each of these x's and find those measurements, but we don't have to do that here. We are just told to solve for x, and so we're done. All right, and so that's it for this example. And this was also the last example for this video. But if you do want to get some more practice, I have another example available on my membership site. So if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.